13 of the world's 20 most polluted cities are in India, and most of our solutions still chase dust. This is the Carbon Circle. Hi, I'm your host Roshan, founder and CEO of Carbon Mandal. Today, we are going beyond PM 2.5 to the gases we smell, breathe, and often ignore, the volatile organic compounds, NOx, and the odorous emissions. My guest today is Lex Vonk and Richard from Indifil, building on a family journey that scaled from solving a neighborhood odor complaint in Netherlands to a global leader in activated carbon filtration, now entering Indian market with intent. We will unpack the science of adsorption, real-world industrial fixes, and how smarter designs and better standards can clean the air that we live and work in. Let's get into it. Hello and welcome to yet another podcast on the Carbon Circle. So today we have Mr. Lex and Richard uh, with yet another topic, which is filtering success, how a Dutch carbon innovation meets India's clean air opportunity. So we'll look at how a family business born from a neighborhood complaints became a global air filtration leader, expanding into India's booming clean air market, right? So we here will be going through a series of topics within this podcast. The first topic that we'll touch is around the genesis of the company, which will be looked at or answered by Lex, and the topics to follow later would be around the problem statement, which is India's gaseous air pollution crisis, the problem around VOC, to explore the scale and health impacts of volatile components, sulfur oxides, nitrogen oxides, and odorous emissions, and why India's air quality challenge goes beyond dust and particulate matter. From there on, we'll move to the next topic, which is activated carbon filtration unpacked. So now this is where we discuss the solution aspect to the problem statement. And the fourth topic that we'll cover today is industrial and commercial applications for the same. And the last topic that will end this entire conversation is with the consulting pathways, that is scaling carbon solutions. So, with that, we will jump directly to the problem statement today, which is Richard, in 2025, 13 out of world's 20 most polluted cities are in India. So, can you explain what air pollution covers and why gaseous pollutants like volatile compounds, nitrous oxides pose different challenges than just dust and PM 2.5 or PM 10?
Well, first, if I can explain what air pollution is, it is basically it's everything that should not be in air. So the
Yeah.
official definition of air pollution is the presence of harmful or excessive quantities of substances in air, whether it's gases, particles, or biological molecules that pose a risk to health, ecosystems, or materials. So basically, it means normal air should consist of nitrogen and oxygen and a little bit of carbon dioxide, and everything else in excessive concentrations can be considered as air pollution.
Right.
Now, what the difference is between gaseous contaminants and PM 2.5
2.5.
is, first of all, it's the appearance. A small particle like 2.5 micron is not visible to the human eye. But if you have a lot of those particles, you can see a haze in the air. Last week I was in Dubai, couldn't see the sun because of the haze, and that's basically because of particles. With gases, you don't have that. VOCs are not visible, also not in high concentration. So it's more like a sneaky danger. You cannot see them. You can sometimes smell them, but some toxic gases are also not smellable, so you don't notice them, but you do breathe them in. Now, the effects of the different pollution is that dust, 2.5 micron particles, that mainly harm the lungs and the cardiovascular system,
Right.
whereas VOCs are more like a chemical toxicity, which affect the liver, the nervous systems, and some of these are even causing cancer. So therefore, the dust is more noticeable in short term, but VOCs are more subtle, and you will see the effects more on the long term. So and then on the long term, maybe people don't even relate them to air pollution because it's the time difference between when you have taken the VOCs and when you got the disease is too long. But
Hmm.
it's still there. I mean, there's long-term effects of VOCs, and that should be taken into account. But if you smell VOCs now, you don't immediately notice that something happens to your body. But in the end, it could be.
Right. If someone were to figure out if they are breathing in VOCs, is there any litmus test? Is there a distinct smell to the thing? How would one know if they are breathing
Well,
in it?
VOCs, there are 600 different types of VOCs. And a lot of VOCs are, for instance, coming from paint, and
Hmm.
you smell those solutions. Some people like the smell, but those are VOCs. It's like solution, it's some people get high on it, but and then you have also gases like formaldehyde, gases like benzene, which are very toxic and not always smellable. Yeah, you can sometimes smell them as a like when you smell glue or fresh paint or those
Right.
kind of things.
Right. I mean, the reason I asked that question is just for the audience or the listeners to figure out if they are breathing in VOCs. So if it has a distinct smell, perhaps they are breathing in those. Would it be right to say that?
Yeah, yeah. Well, but also benzene doesn't smell.
Hmm.
Even if it's not smelling, you can still breathe it in. I mean, VOCs are coming from all kinds of processes, traffic, industrial processes, paint, solutions, glue. So there's all kinds of. I mean, petrol. If you smell petrol, filling up your car, you can also smell some VOC. So those kind of smells are generally VOCs, but there are also VOCs that you cannot smell.
Right. Richard, before I move to the next question, for the audience who are listening in, uh, what is the kind of role that you are presently pursuing at Indifil, and
Yep.
what makes you an expert in this very topic?
Well, at Indifil, I support Deepak and Raghu in with technical knowledge, application knowledge. I started in gas phase filtration in 1994, so it's approximately 33 years. It's a long time.
Yeah,
I'm an old guy, and
with
I've
a lot
seen a
of
lot of
experience, of course.
I have seen a lot of applications in many different fields. So that makes me more like an experienced expert. I'm
Hmm.
not a chemist, but I'm an engineer.
Right.
But I've seen a lot of applications, and that's what I do. So, and also besides supporting the sales, I'm also doing some research and development for new products and new developments,
Mhm.
which we will talk about later on when we talk about sustainability.
Surely. Welcome, everyone. We have Mr. Lex with us, who is the owner of CF Group. Lex, we'll begin with the first topic for today, which is to introduce you and your journey from solving local odor complaints to founding CF Group and overviewing family business and how it evolved into a global air filtration leader. So, Lex, my first question to you is this. How was your family's origin story starting with that first carbon filter from a spray booth influenced your vision and strategy for launching Indifil in India's market today?
First of all, I have to be honest because I'm not the founder. I did a management buyout in 2009.
Hmm.
And to come back at the question, the founder, his brother, he had a spray booth in his backyard. And yeah, his neighbors didn't like it. As you know, maybe Holland is a small country, so everybody lives close together. So when you have a booth in your backyard and you don't have a ventilation or a filter system, yeah, it's not very nice. They had some communication about it, and after that, he thought, okay, let's make a kind of a filter and let's see what I can do. So he made an electric carbon filter and it worked well. So the problem was solved.
Hmm.
And the brother of the founder, he is a very technical guy. So he created, he said, okay, I think I can make a business case out of it. And no, that's what he did. So did they start somewhere in a small place in the middle of nowhere in a kind of a garage. They built the first carbon filters, and yeah,
That's a very, interesting story journey. A neighborhood problem that led to a solution and then became a market solution today. So how do you view this entire journey?
It's a beautiful story. The problem is a little bit the same as what we see now all over the world. Some people in some areas where they live, they have problems with pollution, and we can create a solution. So I think it's a perfect story how it starts, and we can still use it because it's still what's happening worldwide.
When I heard this story or read this story for the first time, I found it very interesting because a genuine problem, many others would have also faced the same problem. But
Mhm.
this one guy chooses to find a solution to it. And that solution then becomes a product which has a market application. And now today that has converted into an organization which is providing solutions globally. So that's a very fascinating journey for me to read. So Lex, now you're at the helm of this very organization today, right?
Yep.
So, what is the vision that you today hold for the organization?
The main vision is that we focused on segments. So we have also a ventilation company, we have a filter company that's more operational in glass houses, and also CF Industrial, that's more a company doing air pollution. And all the companies, we want to be global. So the first step of what we did to hire good people and keep focused on the segment, and we want to have growth country by country, not everything in once. So when we started, we said, okay, now we are going to increase, for example, Germany, and then we go to another country close by. And that's how we started. And then we had when we had enough people, then we said, okay, let's go now for the next step. And let's see where we see that we can be productive or sell a lot of products and what's a good market for us. And then we go in that.
Right. Lex, before you took this role with the CF Group, what was the background that you came from? Could you maybe talk about your journey? Where did it start? How did it come to this?
I was, as a student, I did law. It had nothing to do with any commercials, but when I was finished, I said, okay, now I know what I can. Let's go more commercial because I think I like it more. Then I get a job as a sales manager first in packaging. And that's also how it starts, how I came to CF Group, because CF Group was a customer of mine. It starts that CF Group needed a new sales. So, and they asked me to join them. So that was in 2005, and I started with the CF Group as a sales manager. And
Awesome.
4 years later, the founder, he had a disease, so he asked us, me and my colleague André de Groot, my business partner, to take over the company by management buyout.
Awesome. So you joined in as a sales manager coming from a background of law. You got
Yeah.
into the firm as a sales manager, and you have spent now in 2005 you mentioned. So it is almost 20 years working in the organization or for the organization, rather running organization right now. So
Yeah.
you must have seen the organization grow and reach new heights, right? So what would be the next high that you're aspiring for CF Group?
I think the next height for the group will be a big growth out of Europe. We have our market share, and of course, we win some, we lose some, and we try, of course, to win more and more. But
Yeah.
still, the big growth potential is out of Europe. And so that's why we have now more focus on, for example, India, but also the Middle East and the US. But
Yeah.
the US, it slowed down a little bit now, but more India and the Middle East at the
Right.
moment.
So looking at scaling and growing to different regions of the world, what is your vision for India? How do you see Indifil working and taking shape here in India?
When we started in India, I think 2 years ago, I met two gentlemen from India and we had some conversations, Deepak and Raghu. After conversations, and of course, we knew India already because we are doing business many years in India to buy carbon. So we knew the country, and then after the conversation with those guys, we said, okay, let's set up a new company, and I want to work together, and I want to have you also in the board. I think when you have local people in your company, it helps because they know what's going on. When I'm in Europe, I don't know exactly how it goes in India, and of course, it takes a lot of time, and there's sometimes a culture barrier. Even sometimes in Europe, we see. But I think it helps when you work together with good local people. And I'm very happy with those two guys because they're doing a great job and the first very good steps
Awesome.
with
So,
with the company.
Lex, if you were to, I were a new budding entrepreneur wanting to make big in my life with my organization, what would be those three tips that you would provide me when I'm starting out?
It depends on what do you want to do. You want to make a big company?
Yes.
Okay. I think when you hire people who are better skilled than you yourself. That's one. Be open for everything. The sky is the limit. So be open for everything, even when you think, "Ooh, sounds strange to me," but listen and look what you can do with it and work together. Don't
Right.
do it by yourself. So you have to cooperate with people and companies.
To summarize the three tips that you just provided me, hire, find the right set of people.
Yeah.
Two is always be open to ideas, new ideas. And three is grow together. So that brings in the ownership, cumulative ownership of the entire team put together. Awesome. So, Lex, is there any last message that you would like to give me? If I were to ask you, what does sustainability mean to you? How would you define sustainability?
Okay, for me, the main goal, it should be a great step when we can have an impact on the pollution worldwide. It's not just in Europe or India, but everywhere that we
Globally.
can bring it down, that everybody can live more safe and more healthy. That's when we can do that. For I know we as a filter company, we can't do it by ourselves because we have to do it all together. But that should be the biggest compliment that I can get, that we can have an impact on that.
Awesome, awesome. So, Lex, thank you. We'll move to the research, part of the conversation. So, in India, we have the Pollution Control Board. You might have heard that
Yeah.
the CPCB, right? So, the recent CPCB data shows the VOC levels spiking in industrial corridors. So, how serious is the volatile organic pollution compared to the PM 2.5 today, Richard?
Well, like I said, VOCs can be very toxic, can be very harmful, and many people are working in these places for more than 8 hours per day. So they're exposed to these gases,
Hmm.
pollutions all day long. And when you are talking about dust, you can always wear a mask,
Mask.
and a lot of dust can be captured by a mask. But for gases, it's more difficult. I mean, you cannot run around with a gas mask all day long to take out the gases. So it's more difficult. It's more complicated to overcome. And also, if you are in an area with those pollutions, rain can do and wind can act as air cleaners against dust. And also sometimes for for VOCs, soluble VOCs can be taken out by rain, but there are also non-soluble VOCs which cannot be taken out by rain. And if the rain stops and the water evaporates, the gases can come back into the air. Whereas with dust, it usually sticks to the surface and it doesn't come back. So VOCs, it's harder to get rid of. Of course, if there's if there's a wind, it will dilute, and sometimes it will also react through to other gases, which may not be much more healthier, and it will move to another place. But that's also not a real solution. So it's VOCs are harder to contain. It's harder to clean up. And people are working in those areas for 8 hours. So it's
Yeah.
yeah.
The exposure is longer as well.
Yeah.
Right. And no masks with good filtrates can help them to avoid this.
Well, a mask that can, there are of course masks that can take out the gases, but to wear them all day long is pretty heavy. Usually those masks are used in specific areas for just a short time.
Yeah.
But to wear a gas mask all day long, that's a challenge. I mean, it's a big filter. It's so the mask is heavier than a dust mask, and it's also heavier to breathe.
Yeah.
So to really, I mean, to really take out those gases, you need like activated carbon into your mask just to take it out.
Yeah. So we'll definitely get to the part of the technology behind cleaning of
Hmm.
this VOCs or filtering them. So far what I've understood is when you talk about air pollution. The
Mhm.
perception is largely dust, the PM matters in it, but no, there is also an invisible part or the gaseous part to it, which includes VOCs, the nitrous oxides, and the benzenes and all of that, right?
Yeah.
And a long exposure to these gases is definitely going to create some health issues. That is for sure.
Yes.
So now my next question is, how do they affect business operations, and how can businesses quickly assess their on-site gaseous emissions to meet the national air quality standards, Richard?
Well, especially when you talk about gas pollution, which is odorous, it is not only cannot only be hazardous but also uncomfortable. And if people are in a working area in an uncomfortable situation, they lose concentration, they lose focus,
Yeah,
and they can make mistakes. They become less productive. So that's bad for companies. I mean, the profit will go down because people get less work done. So if they are in a clean environment, if they don't smell all kinds of gases, then they're happier and they can do better work. Now, for instance, if the gas that haven't been mentioned yet is H2S, which is also can be a very toxic gas in high concentrations,
right.
but it's also a very odorous gas. It's the sewer, and the gas comes from sewers, and it's very unpleasant to smell.
Yeah.
And also, even in low concentrations, if you are exposed to H2S all day long, you can get nausea from a pH change in your stomach. So there's all kinds of small and larger effects of gas pollution, which can affect the productivity of people in your company, and which then in the end will affect your profitability of your company.
Yeah. For our listeners, the hydrogen sulfide that you just mentioned, the H2S, if is there an analogy? I mean, if they were to figure out what the smell is, would it be fair to compare it to a rotten egg smell?
Yeah, it is the same. It's rotten egg smell is also H2S, but also just the sewer. Every building has a sewer, and here in India, a lot of buildings have their own sewer treatment plant, and that can emit H2S. And if your air intake is just taking up that H2S and spread it out in your building,
Hmm.
then your employees will be affected. And and
Absolutely.
and and it's the thing is, with Indifil, we can prevent that H2S to enter the building. I mean, there are good filters that can take out the H2S and can prevent this from happening.
Right, right. So, I mean, just comparing with your home country, which is the Netherlands, versus
Mhm.
India, do you see there is necessary for a shift in policy here in India, specifically talking about on this subject?
Well, we always consider that the developed countries are much further in this than the other countries. I don't see that. I mean, yes, we may have more legislation, but also in our countries, the enforcement of legislations is not always that good.
Hmm.
So, and also that's probably because the awareness of the subject is not always there.
Yeah,
So people think, it's a bit of a smell, and it's just it's part of the job, to smell H2S or to smell VOCs. But the effects are long term, and people don't worry about that. Companies are still always focused on profits and on costs, whereas they should also take public health in consideration. And I think that there's a task for the government is to make legislation for public health and to enforce it, so that the companies have to do something about it. And if all companies have to do it, then there's a level playing field. Then there's no problem. I mean, there's no uneven cost burden for the companies. Everybody has the same cost, so you can just put the cost in your price, and
yeah,
then the price will be a little bit higher, because usually it's not that much higher. So the price will be a little bit higher, but also from your competition, the price will be a little bit higher, and everybody does the same, and we're all healthy. And that's
right.
what we want to do.
Right. So there is surely a problem that exists here in India, and maybe there is more opportunities here as compared to the developed nations, given that there is a growing demand for more products, which means more industries, which means more possible sources for volatile compounds, hydrogen sulfides, and all of that. So there is likely a option or a solution that is necessary in this very area. But Richard, just out of curiosity, this might have been naturally occurring chemicals as well. I mean, maybe the concentration might not have been as much back in the past. So is there a natural solution to it? Are there any specific plants or trees that kind of do this filtration better?
I don't understand the question quite well. Can
No,
you repeat?
okay. Let me rephrase that. So this problem of VOCs or the gaseous air pollutants, as we can call
Mhm.
it, this might have been naturally occurring processes back in the past. Maybe the concentration of them might not have been as much as it is today. But is there a natural solution? Are there any specific kind of trees or specific kind of plants which manage this better? Is there a solution around that?
Well, VOCs and hydrocarbons are generally molecules from, carbon and hydrogen, and they tend to come from refining of oil
Hmm.
and gas. So basically, it's not a real natural gas,
Occurring one. Hmm.
but the VOCs will react, with, for instance, ozone to be oxidized, and then you break up the molecules into CO2 and H2O. So yes, it will eventually will break down. But if the concentration is too high, or if the generation of VOCs is higher than the nature can break down, then of course you still will have the VOCs.
Right, right.
Um,
So that gives me a good segue to the next topic, which is talking about the solutions specifically, which is activated carbon filtrations
mhm.
that we're going to talk about, because nature-based solutions might not be as effective given the high concentration of this very gaseous air pollutants, as we have discussed already. So in this very subtopic, we will cover or dwell into how activated carbon captures and neutralizes harmful gases and the science behind adsorption versus particulate capture and the key design consideration for a gas specific solution. So this is something Indifil specializes in.
Right.
My first question here to you, Richard, is what makes activated carbon uniquely effective in removing gaseous pollutants compared to other filter medias?
Well, if you look at the different pollutions, so like I said, PM 2.5, the name already says it. It contains 2.5 micrometer particles. If you look at gas molecules, you're talking about zero point 0.3 to zero point 0.6 nanometers.
Hmm.
So these
Extremely
particles, or these
small.
parts, are 4 to 8,000 times smaller than PM 2.5. So to remove them mechanically, it's almost impossible. Then you have to use membranes, which are very expensive and don't allow a lot of air to be treated. And activated carbon, what it does, it attracts those molecules to the surface. I always compare it to a magnet or to even gravity. I mean, like, we are people, we are adsorbed to the Earth. We are sticking on the surface of the Earth, and Earth keeps
Okay.
us from floating into space, right?
Yeah.
And that's basically what the activated carbon does. It attracts the molecules to the surface of the carbon. Now, to give it some capacity, we've tried to increase the surface area of the carbon. Because if you just have a carbon pellet, and there would not be any extra surface area, then it would be saturated within no time. So we made the carbon very porous.
Hmm.
For instance, 1 gram of activated carbon now, because of the pores, has a surface area up to 1,000 square meters. So to compare that, 1 kilogram of carbon could contain the surface area of 140 football fields. So, and that,
Okay.
that is done because of the pores, so with steam and pressure and high temperatures, we created pores into the carbon, which created this extra surface area for the molecules to be attached. And that's why carbon can take up like 20 to 50% of its own weight on gases from the air, and these gases are all stored in those pores. So, and basically that's how the gas is removed.
Right. But do carbon have some special affinity to this specific kind of gases, or do they have affinity to all kind of gases?
Well, you have different types of carbon for different types of gases. The gases have different molecule sizes, so you also have different base materials for carbon, which have different pore sizes. So a large molecule doesn't fit into a small pore. But also we can enhance the carbon with impregnation. So sometimes we impregnate the carbon with chemicals to give it a better capacity or a better reaction with the gases. And therefore there are there are many different carbons that we can use. And that's also my job. At Indifil, I can choose the right carbon for the right application, so
Right.
that the capacity is okay and the efficiency is okay.
Right. So it would be first be important for you guys to figure out what kind of gas or what kind of pollutants are present in that particular area, and
Yeah,
then make the right sort of carbon blend for that very air pollutant. Would that be a fair
yeah.
process too? Okay.
Yeah, to get a right solution, it would be ideal for us to know what the pollutants are and what the concentration of the pollutants are, so that we can size the right system and the right type of carbon for the job. And sometimes you blend the carbons, sometimes you make multiple stages, so behind each other. It depends on the situation of the pollutant.
Right. So let's take a very specific example now, Richard. So how do you size a carbon filter system for a chemical plant, let's assume, which is emitting 200 ppm of benzene?
Well, the success of removal of gases is depending on the capacity of the carbon to remove those gases, and the contact time between the air and the carbon. So if you have a high concentration, you need a longer contact time of the air with the carbon. So. So what we do is we calculate the total amount of gas that needs to be removed. We take the concentration, we take the airflow, and then we can calculate how much gas in total needs to be removed in a certain time frame. Then we look at the capacity of the carbon and to say, okay, we need so and so many kilos of carbon. We look at the concentration and we determine what kind of contact time we need, and with those parameters we can design a system which can incorporate those enough carbon and enough contact time, so that we get the ideal situation. Now, sometimes we also, most of the times we also take into account, of course, the pressure drop that we can handle, because I can make a very large filter and which needs a very high pressure drop for the air to push through. And pressure
Right.
drop is basically the force that you have to give to the air to push it through the filter.
Filter.
So the larger the filter and the higher the speed, the
Yeah.
more force you need to be. I sometimes compare it with if you have a straw. If you go to a milkshake shop and you get a milkshake, when you have a straw with a larger diameter, it's much easier to take the milkshake out than when you have a very small straw. And that's basically what pressure drop is about. So if you have a high pressure drop in a filter system, you need a very strong fan, which takes a lot of energy, and that costs extra money, and it's also not sustainable. So we try to also take that into account. But the most important part, of course, is to remove the gases. So we don't want to compromise on the gas capacity with the pressure drop, but we do have to take that into account.
Oh, okay. So this is very interesting. I mean, for me, also coming from an engineering background, there are a lot of
Mhm.
parameters that kind of are at play here to have the
Right.
right design and setup here. Of course, the surface area of the carbon itself, I think, is one parameter, but
Mhm.
the concentration is other. Then you have the amount of time or exposure this volatile compounds have to the activated carbon, along with the pressure drop. So there are multiple parameters that you have to consider before actually making a suggestion or making sort of a recommendation for a company or for a entity to have a better sort of a solution providing there. Correct?
Right.
Right.
Yeah, that's correct.
Right.
Yeah.
Awesome. So, but everything said and done, at the core of the solution that you provide is activated carbon. And I'm now going to ask you a few questions around uh, where are the sources? I mean, what are the sources for finding activated carbons?
Activated carbons, like I said, there are different base materials for activated carbon, and the ones we use for air purification are in general coal, coconut shell, and wood. Now, India is a very big source for coconut shell carbon, as well as Southeast Asia, like Malaysia and Indonesia. And coal-based carbon is mainly coming from China, mainland China. Wood-based is also India and Southeast Asia, so it's different areas where it comes from. Now, in Europe, we don't manufacture significant amounts of carbon
Mhm.
because there are no coal mines, and we don't have the climate for coconut. So it's basically coming from these areas. And what you have to bear in mind is that not all carbons are exchangeable. I mean, if you look at the three base materials, the main difference between the materials is the hardness of the material.
Right.
So coconut shell is very hard, very much harder than coal, and coal is harder than wood. So
Mm.
if you have a softer or a harder material, the pore size will differ. A softer material will have a larger pore size, and a
Mhm.
harder material will have smaller pore size. So there's already a distinction between the applications and the type of carbon that you want to use.
Right.
If you have large molecules, then you don't want to use a carbon which has very small pores because the molecules will not enter the pores.
Right. So coconut shell is definitely one of the key sources for activated carbon. I mean,
Mhm.
given the high quality that it has, and I mean, we in India, at least in the southern states of India, there are a lot of coconut plantations. I mean, it is one of the key crops in this region. So my question is, how much of CF Group's activated carbon demand can feasibly shift to Indian coconut shell sources, Richard?
It's a difficult question because, like I said, first of all, it depends on the application that you do. But for VOCs, coconut shell can be very good usable because VOCs in general are small molecules, or a lot of VOCs are small molecules.
Mm.
But there's also the other thing is that the availability and the price. Still a lot of companies just want to have the best price. And at the moment, if we look at coconut shell-based carbon, it's pretty expensive because of a harvest situation. Coal-based carbon is, of course, it's coming from a coal mine, so you don't depend on a harvest or those kind of things.
Right.
And in general, it's a little bit cheaper. But at the moment, coconut shell is approximately almost two times as expensive as coal-based. So although I do prefer coconut shell and wood-based because they're more sustainable resources.
Right.
The material is coming from a renewable source,
Sources.
whereas coal-based carbon, of course, is just yeah, it's coming from a coal mine. But yeah, we do depend on what customers are willing to pay. What are they willing to pay for a sustainable product? Um, and that is also a limiting factor. We could do more. We could do yeah, a lot more, especially also with Indifil here in India, because we don't want to depend too much on countries like China. Because if you put every power in those countries, you don't know what's going to happen.
Yeah.
And the transport costs of having local carbon to be used inside India is of course also a factor.
A factor to consider.
Yeah, not only cost but also the sustainability of that.
Absolutely. The supply chain definitely, for the viability of it,
Right.
having a reliable source is crucial. But there's this very point that you made that the cost of activated carbon produced through coconut or softwood is 2 times more expensive as compared to coal. Uh, do you see a foreseeable solution to this, maybe through policy or things like that?
Well, I want to correct this. Coconut shell is more expensive than wood. Wood is quite low price as well, but wood has a different, it's a very lighter material, so it has a lower capacity. So that's a different story. But talking about coconut shell, it has similar characteristics as coal. It's more expensive. How can we overcome that? Maybe door by yeah, I don't know. How can you guarantee a harvest? I mean, it's that's the big question all over the world. So um, I don't know how much is subsidized in certain countries for industries.
Hmm.
I don't want to suggest anything, but yeah, it's a matter of how do you say that? Market working. It's how much is available. That depends on the price, and with coconut shell that will differ more than with coal.
Right. Richard, the kind of angle that I'm coming from, or the POV that I'm coming from, now that Europe is coming up with CBAM as one of their carbon border adjustment mechanism, whether taxes levied on carbon products or carbon intensive products rather. So do you see this kind of policies playing a factor with the choice of raw materials for activated carbon?
At the moment, I don't see that effect yet. Maybe in the future you will see it.
Hmm.
But then there also has to be knowledge within the governments to know the difference between coconut shell carbon and coal-based carbon.
Right.
So we have to educate those people that, they will probably see carbon is carbon and it's all black, and they don't see the difference. They don't see that coconut shell carbon is coming from renewable sources, whereas
Hmm.
coal-based carbon is coming from a coal mine. So that's also maybe our task to educate
Educate.
the legislators to know what the difference is.
Great, great. Okay, so far what we have covered is we have looked at the problem statement of
Mhm.
air pollutants on one side, and we also looked at the solution side of things, which is activated carbon. Now, the next part of the podcast that we're going to cover is the industrial and commercial applications of the same. We will try and examine how carbon filtration is deployed to remove odors and toxic emissions there, Richard. Right? So, in India, Richard, which sectors contribute the most to harmful gaseous emissions? I believe you have touched upon a few paints and oil and gas segments and all of that. But which are the sectors that contribute most to the harmful gas emissions and therefore represent the greatest demand for carbon filtration solutions? And which states show the biggest demand for the solutions here in India, Richard?
Yeah, well, basically, all heavy industry and all traffic contribute to the emissions of hazardous gases.
Hmm.
So it means that many states show demand for carbon filter solutions. If you look at the heavy industry, I looked at the market situation. You have mineral industry in the northwest of India. You have a lot of petrochemical in the north. Sorry, the mineral is in the northeast. You have a lot of petrochemical in the northwest, and then you have some mixed heavy industries in the south. Um, but and those are of course areas of concern where we need this kind of solutions. But if you just look at traffic, I mean, there's more than 50 cities in India with more than 1 million people living in there.
Hmm.
So there's a lot of traffic in all those cities, and all that traffic is emitting all kinds of VOCs, NOx, SOx, all those kind of gases. And I think in those cities there are more than 150 million people living there. So
Right.
and those cities are all over India. They're not in a specific state, they're all over India. So basically, to just appoint some states where there's more opportunities than others, I think in every state, every city, there's a lot of opportunities to clean the air. Because yeah, traffic is just emitting a lot of gases, and we're far away from having 100% electric cars.
Yeah.
So until then, we have to clean the air, and especially the air that comes into buildings. So the indoor air quality, and needs to be okay. Sometimes people say, okay, we're taking fresh air, but how fresh is the air that you're taking in? Usually they put in a good particulate filter, back filter, or HEPA filter, but then they're forgetting about the gas contamination. And so, and that's what I also want to. It's there's a lot of gas in the air, and sometimes the air in the inside smells bad, but the air coming from outside doesn't smell, but it's worse because of
Hmm.
the VOCs and the other gases. So it's yeah, I think that is maybe even a bigger opportunity or challenge to do than just the industrial side,
Right.
because it involves many more people.
Hmm. So the biggest areas where the solutions can be implemented is very clearly that you stated is one is traffics, because this is something that is prevalent in all major cities across the country. But other than that, the ones that you mentioned is mineral industries, chemical companies. So these are some of the major sort of areas or sectors where the solutions that you guys have built is going to be a right fit.
Yeah, we don't with activated carbon solutions, we don't do the big chimneys, where the gases are emitted, but we do the smaller emissions and the air that comes into buildings around those industries. So
Right.
where people are working and where people are living. So
Hmm.
if you're living next to a petrochemical industry or a paper mill or a sewage plant, then we can take care of your indoor air quality, the air that comes in to remove all the gases. To remove all the VOCs and hydrocarbons and gases from the industry, it would require
A
much
larger.
more carbon, and that is too much. I mean, to do that, you have to change maybe some industrial processes, which goes too far for this podcast. But we can do the protection of the people in the offices, in the apartments, but also if you're working in a factory where a lot of solutions are being used, we can take out those solutions. We can take out those VOCs with fans and then run them through a big
The
filter
filters. Yeah.
and either throw them back into the production area or throw them outside. But at least you won't have those VOCs in the environment.
Yeah. That would safeguard the health of the workforce in that very area. Right.
Yeah.
Awesome. Awesome. Okay. So my next question to you is this, Richard, that what are the main challenges that you encounter while selling carbon filtration solutions in India? And how do you plan to overcome them if there are any?
Well, like I said before, the biggest decisions are made based on cost by companies. So we cannot just rely on companies to do it themselves. We have to make legislation from the government to force companies to stop or to reduce emissions from hazardous gases.
Hmm.
And also to work better on public health. I mean, especially, and not only the big companies, because if you look at the big international companies, they have all these policies already in place, but also the smaller companies. You have to think about your people and how you can protect them against this hazard. You want to have your people grow old, so then you have to do something for it.
Yeah. Grow old healthy.
Grow old healthy, yeah,
Yeah.
absolutely. And the government has a role in this to make legislation for public health and to enforce those rules. And the second part is maybe more important than the first part, because you can have rules, but if nobody enforces them, then nobody's going to stick to it. And like I said before, if every company has to stick to the rules, then it's a level playing field again, and so they don't have to suffer from extra costs because everybody will have those costs.
Right, right. So it is important for the management to understand that the safety and health of their workforce is crucial. I mean, it will reflect on the bottom line, right? And on top of that, if there is a policy that kind of drives or mandates organizations to take this up to safeguard the health of their workforce, perhaps this will be a solution that will be largely implemented here in India, right? Would you
Yes.
agree on that, Richard? Yeah, awesome. So Richard, if I were a facility manager and I were to make a decision between a standard and a custom carbon filter cartridges for commercial spaces, how do I do it?
Well, you come to us, to Indifil, and you present your problem, and then
Okay.
we look at it. We make some calculations. We look at the different gases and the different types of carbons that you would need,
Mm-hmm.
ideally,
Mm-hmm.
and we find the most economical solution. Now, of course we try always to look at standard solutions first because they are the most economical and that's in the best interest of customers. But sometimes, or most of the times, you also need some special carbons, or you need some special amounts of carbon to reach the goals that the company has. And also, of course, what we're trying to do is to design the systems in such a way that they don't consume too much energy,
Mm-hmm.
and to make it in a right how do you say that size so that it fits on the premises. So that is how we customize the filters. But we try to use standardized filters so that it's the most economical for the customer. Like with dust filters, also carbon filters. A lot of carbon filters have been standardized over the industry.
Mm-hmm.
So we like to stick to them. But sometimes we make some exception, and we make a specialized filter.
Right, but before I make a decision, I mean, the first point that you made here is the cost part of it, right? For
Mhm.
a facility manager to make a decision, that the costing is one key parameter to kind of consider. So, what are the aspects that will affect the cost of the entire solution?
Well, there's always this discussion between CapEx and OpEx, so capital cost and operational cost. And sometimes, those costs are coming from different budgets.
Mm,
Sometimes the total solution, if you look at the solution over time, the CapEx can be, or the investment cost can be a little higher, but the operational cost will then benefit from that.
right.
And that's what we are trying to discuss with the customer. So maybe sometimes they have to invest a little bit more in a better solution, but in the end, the cost will be lower in operational situations, or it will earn back in on the longer term. And that's the discussion that we then have with the customer. I mean, if you take just a standard carbon for sometimes a difficult gas, then you will have a very short lifetime of the carbon, and you
Mm,
have to replace the carbon very often. Whereas if you take a specialized carbon for that same gas, it will be more expensive in the first place, but the lifetime of the carbon will be much longer, and in the end, you pay less. So that's the mechanism that
the
we
the
we're
the
looking
trade-off that you need to make between the
at. Right.
capital, the capex and the opex. Great, great, Richard. You've been patiently answering all my questions, and this so far has been very enlightening for me as well to kind of hear the technical aspects of the carbon filters here. Now we'll move to the last part of the entire conversation, which is the consulting pathways. So where we will discuss about scaling carbon solutions. Now here, my objective is to discuss the regulatory guidelines. Guidance for life cycle assessments. Now, LCS and EPDs are now being spoken about because that is one of the ways where a consumer can get to know the environmental aspects or the sustainable performance of a given product or a service, right? So my first question here is this, Richard: how does Indifil see sustainability shaping in the future, and how important is showcasing the product sustainability through life cycle assessments and EPDs for differentiating them in the market?
Well, at Indifil, what we try to do together with our mother company CFI is to aim to more reuse of materials.
Mm,
In the filter market, what you still see the standard is like disposable. So when a filter is saturated, or when a filter is also with particulate filters, when they are full, then we throw them away and buy new filters. Now, the technology is there that to regenerate or reactivate carbon, but there are some hurdles on the way.
mhm.
One of them is cost. It's not typically much cheaper to regenerate carbon than to make new ones. So the customer and us, we need to focus on sustainability, not just on costs. Um, Also, we try to make our filter cartridges more reusable. So can we refill them? Can we use the material again? And that is good. And it does, it also gives another advantage. It's not just the sustainability of all things, but also, like I said, with coconut shell carbon, we are depending on the harvest. But if we can reuse the carbon, then we're not
Mm.
depending on the harvest because the carbon is already there. We only have to reactivate it.
Right.
And we are less dependent on imports from other countries. So it cuts both ways. So we're trying to find solutions for reusal of activated carbon and our filter
Right.
cartridges.
But presently, has CF Group taken an initiative to measure the carbon footprint of the product that you guys have built, or is it in the pipeline?
We are ISO certified, ISO 14001, so we have to do that. Yes. Of course, with carbon, I mean, the product is carbon is C, so the product is 100% C, and if you burn it, it's 100% CO2. So it's basically if you dispose it, then that's what it is. So every filter that you can reuse is contributing
Saving
to
of the carbon
decrease of
emissions.
yeah.
Yeah. So this very process that you mentioned of reusing the filters, does it require you to kind of have that very filter back in your facility for it to be reactivated, or can that be done remotely?
There are some developments to do on-site reactivation or regeneration. Reactivation generally needs to be done in our factories because of the technology. But there are also some developments to do on-site regeneration. So then you really clean the carbon. With reactivation, you do actually the same as when you manufacture it. So you just make the pores a little bit bigger, and with that you take out all the contaminants. Um, yes, so basically we have to get most of the carbon back to our factories. Yes.
Right. So, I mean, the discussion that we've had so far is clearly with one clear objective, that is to build a sustainable Bharat, right? We are talking about sustainability here. So, what support do you need to enhance your sustainability performance, Richard? And how can we at Carbon Mandal assist you in this very journey?
Well, this podcast and all these kind of awareness making is important because people need to know what it's all about, and also we need to how to say that convince the government to sometimes look into the legislation of things. If I want to reactivate carbon, and then I have to move the saturated carbon back to my factory. But that is basically it is transporting waste because saturated carbon is now seen as waste because
Hmm.
there's a lot of gases connected to it,
With
and
that.
that's with good reasons. I mean, it is waste, but it does all the paperwork and all the legislation makes it difficult for the saturated carbon to be transported back to the regeneration plant. So what we should do, and what the government and us and all our communities should think about, is how can we make this more workable and
Mm.
more affordable, so that it's not very expensive to do this. Now sometimes also in Europe we have to have all the carbon tested that we're going to transport to make sure that there are no too hazardous gases on the carbon, and can we have to specially package it, and that makes it the whole regeneration process very expensive.
Mm.
And then sometimes people say, okay, well, if it's more expensive than new carbon, we'll just buy new carbon and we'll dispose it.
Yeah.
So we have to make it easier to regenerate, and the government can help with that by looking at the legislation. How can we make it more workable? And also, you and I, we have to make everybody aware of the situation, so that everybody can help a bit. Yeah, making this a cleaner world.
Richard, thank you so much. We have captured a lot and rather covered a lot of topics in this last 1 hour. So, Richard, thank you so much. It is a
Yeah, and
pleasure. Sorry, yeah, you were saying?
Yeah, we like to, we like to, as Indifil, we like to, talk to people who are in the industry to let's come together and make this work. I mean, we like to talk to consultants, to users, to any legislators to make this workable so that we can enhance the public health. Because otherwise in 20 years time we will see all these effects and we will say,
Yeah.
okay, we should have done something 20 years ago.
Yeah, and the time would have already passed, right?
Right.
Awesome.
Right.
Richard, thank you so much for your time. It was a absolute pleasure having you on this podcast and conversing on such an important topic. It is perhaps one of those topics which will be an eye opener for many. So yeah,
Okay.
thank you. So that was a podcast that we just recorded where we looked at the air filtration as a subject. We looked at the problem statement of air pollution caused as a result of volatile compounds and some other gaseous substances. We looked at the sources of them. The solution for it does exist, which is activated carbon, and we also covered the topics around the applications for the same. So I would like to extend my gratitude and thanks to both Lex and Richard for being a part of this. And if you are somebody who's interested to get in touch with them, we will put the description in the description, the website link, and also their LinkedIn profiles. Feel free to get in touch with them.